Thanks for joining us today as we take a deep dive into the new Surface Laptop Studio. But before we begin, we would like to acknowledge the traditional custodians of the various lands on which we live, work throughout Australia, and the Aboriginal and Torres Strait Islander people viewing this event today. We pay our respects to elders both past, present and emerging, and recognise and celebrate their ongoing cultures, continuing connection to the land, waters and community. Our respect also extends to all First Nation and Indigenous peoples, as well as their ancestral lands. We are grateful to those who have created pathways for us to live with the many benefits we experience today. Welcome to the second of 3 webinars where we'll dive into some of the features of the Surface Laptop Studio. This week we're focusing on power users, and next week we'll talk more about health and other industry use cases. Throughout these sessions, we'll bring to life why Surface and why the Surface Laptop Studio. Don't forget to register for next week's session. We'll chuck links in there, and especially just if you've got any leftover questions after today, you can ask us anything you like. So your presenters today. So I'm Michael Townsend. I'm the Surface Product Manager for Australia and New Zealand. I'll be the host today. I class myself as a bit of a power user. I'm loving the processing performance I'm getting out of the Surface Laptop Studio. Unfortunately, I'm not on it right now because I have to present from a different machine. It's right here, but it is my daily driver. Thankfully, Peter Lewis and JT, who I was concerned weren't going to join me today. JT is recovering from some wisdom tooth surgery. Peter had a dog at the vet last night, but I'm very happy that you're here to support me today. So Peter is our Surface engineer, and he's a bit of a power user himself. He'll take us through virtual machines and some of the performance aspects of the device and where it fits in the rest of the range. JT and Simon run our Azure developer communities, and they've been playing with the Surface Laptop Studio over the last few weeks, and they'll share their thoughts as well. Housekeeping or the rules of engagement. This is webinar, but it's via standard Teams meeting, and we wanted to keep it as interactive as possible for our early adopters of Surface Laptop Studio. We want to hear your thoughts, so please pop questions in the chat throughout, and we'll be answering as we can, and we've left some extra time at the end, so don't leave too soon if you've got some questions for us there. Please stay on mute. But come off if you want to ask us some questions, and feel free to leave your camera on or off. This session will be recorded, but we will cut it and we'll cut the names and faces out before we put anything online. But I just wanted to make you aware that this is being recorded. So today we'll be focusing on the power users, but the Surface Laptop Studio does suit a range of user needs. So creatives and architects, these devices have been always well regarded in the community. Beautiful screens, pen and touch, and you know, I think kind of the right size as well, 14.4 inches. They have HDR Dolby Vision certified 120 hertz screens that make this, you know, a media dream device. You can also run 2 4K external monitors at 60 hertz. So a lot of options there for the creative and architects as well. Government and healthcare, we'll be talking about that a little bit more next week, but power, portability, security, all essential, combined with versatile modes of, you know, standard, you know, laptop, the stage mode, which I really like. So that's kind of like that mode there. And then also you kind of tablet for writing on there, and you can flip the whole thing around. So if you're doing a consult, that's kind of one of the modes there that could be interesting in that environment. But again, we're going to talk about that a little bit more next week. But, you know, everything right down to, you know, telehealth consulting and a great 1080p webcam on that. Higher education, Surface has been a favorite in education, you know, especially when it comes to pen and touch. I really love the pen sticking to the bottom here. You know, that's a big issue, especially for students, and even for people in corporate who are too ashamed to ask for that replacement pen because they lost it early. Great little update there. But really, with updates to GPU, this does open it up for STEM users, AI, large data sets, engineering, and of course, still the creative side there. And really today, we're going to focus on power users, developers, and data analysts. So I wanted to gauge what your requirements are from a performance device. You will see a poll pop up here, but we've seen from our research that devices are more important than ever, with most of us, many of us, still working remote or at least in a hybrid work mode. You know, devices are our portal into the office, the productivity and collaboration machine. Hybrid work has driven huge device refreshes, and customers and users have just found they need more power, they need better audio and video for conferencing. So end users not only need, but they're demanding better devices. We've got partners, Microsoft specialists, and customers on the call. So again, please ask us questions throughout. Feel free to come off mute if you want to engage with any of the speakers, or just ask us questions throughout the chat. But I'm going to hand over to Peter Lewis now. So thanks, Peter.
Thank you, Mike. Just looking, I'll take control. I always forget to do that. Hang on. Just looking at the polls as they're coming in, I can see this device is going to pretty well suit the requirements of most of the users on here, CPU being a big draw card. So if you're using our, I didn't have pen on the list, CPU is, most power users, if they're using a Surface today, are probably on a Book 3. And they'll, if you're on a 15-inch Book 3, you're used to the larger form factor, etc. But a lot of our users, particularly in the education space, are using the i5s and the lower power devices because they like the versatility of the Book 3, the fact that it can be a tablet and can be a laptop, etc. So some of those users might look at this device and say, okay, I don't actually need the graphics card. I don't need all of these extra pieces, but I do need the versatility of that device. And the Pro 8 is usually a very good choice for those sorts of users because they come to understand that portability is the most important part. But power users generally don't fit into that category. And same goes for laptop. If you're using the laptop form factor, like the Book 3 that I have, I'll be honest, I very rarely undock that from the base, and it stays in laptop form factor most of the time. So for me to migrate, if I'm not going to be a power user and not using the graphics card, the laptop 4 is a great option. But if, like most of the people on this call, you need a bit of grunt under the bonnet, a bit of CPU power, the Laptop Studio is going to be the device for you. We have taken the step to move away from the U-class or ultra-mobile processor, and we've moved into the H-class processor. And this means that this CPU can throttle up to around 65 watts of processor power, so it can run a lot harder and a lot hotter. And yeah, so if you just need that processor power and nothing else, there is an i5 in the mix, but generally speaking, most people would be looking at the i7. And most power users will be, like me, wanting a graphics card as well. So the device that I'm talking to you on at the minute is the i7 RTX A2000. And yeah, I have to say I've pushed this thing around, not to the level that a developer might, because I'm simply not a developer. I can see Simon getting excited, but yeah, so I do a few different things, but we'll more on that later. Okay, so if there's no questions or comments, we'll move to the next slide. One of the things that engineers and a lot of people that are out there that do many of the design work, which is probably the more creative space, they require the high-end GPU, and the A2000 is certified against these particular apps. We've taken a lot of time to work with these vendors particularly and ensure that our device is certified for these particular products. One of the things that struck me as someone's just got a bit of background noise there. One of the things that struck me as interesting, because the last time I touched AutoCAD in an engineering sort of product, it was many, many years ago, and it was very much like technical drawing with all of the different angles, etc., and the engineering space. Whereas you can see in the image behind me, that's created in Revit, and it's traversed from engineering to almost art. You know, you see the 3D imagery and the reality of the water in the picture, etc. That's all going to need rendering engines and things like that. So yeah, I know that I'm well out of my depth in that space, but this product is certainly not. So essentially that's, you know, on the left side we've got more of the engineering space, those certified apps, and on the right we've got the more creative apps with the Adobe suite, etc. So I'll move on to the next slide.
Peter, actually, just before you move on,
yep.
We did talk about this once before. The certifications, are they for both the 3050 and the A2000 on these ones on the left-hand side?
Yeah, for the most part, yes. They're definitely for the A2000. These are all certified. That's the most certified GPU in this space. There are some that are not certified. It's not to say they won't work, but they didn't go through the ISV certification process. Like a good example of that is the Siemens Solid Edge product. That's certified for the A2000, not for the 3050. But yeah, there's no reason to say that it wouldn't work, but you're certified to have the best experience possible with the A2000.
Yeah, and I can see Lol have pasted the link, which has a bit more detail on those certifications and which graphics driver. The other one, and I'm going to paste a link here as well, is NVIDIA Studio. So just by chance, we've called it Studio, and NVIDIA also has Studio certified. So there's Studio certified Studio certified drivers. There is also they've got a gaming set of drivers as well. I've used both. I've tried to get the most out of Fortnite and playing with my son, but I didn't notice a whole lot of difference in using even the Studio certified drivers, which are more for kind of those applications even that you see on the right-hand side. But what do you suggest? What drivers should people be using?
So it'll depend on what you're doing. Obviously, if you're doing the high-end graphics work, etc., the NVIDIA Studio drivers will give you some more options and more configurability than our particular drivers. The drivers we have are definitely, you know, the same driver set, but we don't have necessarily the same configurability in them. But what you do need to know, and as a normal power user, you're probably well aware of this, if you do install a third-party driver, you were then required to update that driver yourself rather than rely on Windows Update to do that, because you break that driver chain. Not necessarily. Sometimes we can supersede those drivers in some situations, but we try to allow the best of both worlds for users so that they can, if they want to, control it and drive that that path on the machine themselves and have the more versatile, you know, the drivers that have all the options, etc., versus the more functional drivers that we provide. But you will get the same experience across the two of them. It's just down to configurability, basically. And I think that's the same with the game drivers and the engineering or creative drivers that you get with NVIDIA. Okay, now, unless there's other questions, I'll move to the next bit, which is more around what I do on the device. And it's about really virtualization. I don't tend to push the graphics card and the that end of this product too much, although I have got my team set up to utilize the discrete graphics card on this device, and it just hums along. But in this instance, one of the things that struck me as really quite cool was how quickly I managed to get a instance of Server 2022 up and running on this device in Hyper-V. This instance, so we won't go all the way through this video, but you can see it took me just a little over 3 minutes to do a full install of Server 2022, and you can actually see the CPU performance there. It's there's a few bursts here and there, but really at no point does it stay in any regular state over around the 30-35% mark. And at this point, I've given this particular machine quite a bit of resources, 8 gig of RAM and 4 virtual CPUs. And yeah, it doesn't break a sweat. It just hums through the process. And I was ready to start configuring the domain controller within 3 minutes. So yeah, I was very, very impressed. I'll move on to the next one, unless there's some questions. One of the other things that I find drives the load on a machine and on a CPU in particular, Windows Update sadly can be a little bit greedy in the way that it operates. It does do installs, and it does utilize processor where it can. And so in this little video, I was doing updating 3 virtual machines. One of them was a Linux machine, doing a full Linux OS upgrade up to 2004, I think it was, and doing first round Windows updates on 2 server devices. And you can look at the CPU there across all of them. It's not really getting over the 30% mark. It just runs with this stuff. It does not break a sweat as it's going through processing things. But I'd love to know what other high-end processing things people are doing out there. And I'm sure JT and Simon will tell us some more and really put it through its paces. But one of the reasons it really doesn't break a sweat is because of the advanced cooling that we've put in this device. So generally speaking, there's 1 fan and 1 heatsink, and it's a very, I don't know, is that video running? No, there we go. 1 fan, 1 heatsink, and with some devices, particularly on ultra mobile compact devices, there's not a lot of breathing room in these. So we redesigned the chassis for this one to allow more airflow. We've put dual actively controlled fans in there with big heat pipes that run across both processors so that they can cool the device in the most efficient way. You'll see in a sec, you can see on this demo there, the actual flow of air is greatly increased. And if Mike holds up his studio there for us, you can see right on, there's a big vent that runs right along both sides, and that just allows the thing to gallop and breathe. How does the hardware perform on deep learning workloads such as TensorFlow? Well, so it depends on the processor you have, but it has, one sec, it has 80 tensor cores in the A2000. So it will manage, it's probably better for these other guys to answer that question, but I'll have a go and they can correct me where I'm wrong. So it's got the 80 tensor cores to do the TensorFlow processing. One of the things you may find that this doesn't do that perhaps a desktop machine or a higher end device does is that it only has 4 gig of NVRAM for actually loading those data sets and things like that. So you may not get quite the processing power that you might get out of some of the larger units out there, but it is a mobile device. It is a laptop essentially. So the target for these sorts of devices is to be as versatile as possible. It may not be the best in class for some workloads, but it's designed to do enough to get you there. So with that, and that's actually a really good segue to throw over to JT and Simon, and they can talk a little bit more about what the developers need and how well it works.
Thanks, Peter. I might just quickly take control. Let me take control. Okay, and my screen's changed, so we'll go to the next screen. Yeah, so my name's Simon Waite, and I'm joined by my colleague in Melbourne, JT, who's waving there on the screen. We are backroom guys that do all the coding, and so when this device was first coming up for availability in Australia, Michael reached out to JT and myself and said, would you like to put this new machine through its paces and give us a perspective on what this means for developers? So great question in there about tensor cores and TensorFlow. So we will talk a little bit about that, but I wanted to bring JT on, and we have a sort of similar background. We've done a lot of dev work in our careers. So we like to do odd stuff. We've built big and small things. We've built Linux and Windows things. So JT, maybe you want to unmute yourself and let's talk a little bit about, what paces we put the machine through from a dev perspective.
Yeah, sure. So I guess for most of the stuff that I put, I wanted to really see how this device would hold up doing just a bunch of sort of random stuff that I do during the day from a development perspective. So I loaded it up with all my favorite tools. So I had Docker on there, I had WSL2 under Windows 11, had VS Code, I had full-blown Visual Studio, and I sort of jumped around doing as many things as I could. And just to really kind of see if I could get some heat out of it, I ran a couple of Teams meetings at the same time as well. But what I was really impressed by is, I was compiling some very large .NET solutions. I was doing some fairly heavy-duty Node apps as well. I do sort of, mono repo stuff where I have a bunch of Azure functions and then some web apps that plug into that, and then some other bits that plug into that, and build it all and deploy it all out. And the device didn't really skip a beat while I was doing that. And I was still able to have, my music playing in the background, my email running. So, probably for a developer, I would say probably a pretty typical multitasking type situation where I was just trying to see, like, the limit of multitasking came down to how much my brain could focus on at the same time, not how well the machine could hold up in that scenario. And I know you did some slightly different things, Simon.
Yeah, no, look, I would agree. The ability for this machine to kind of do some of that heavy lifting in the background while you continue to do other things is quite impressive. So the example I have is fresh machine, first login. I'm thinking, what's the most difficult thing I can push on this machine as a fresh machine? So I went to the .NET 7 GitHub repository and I cloned that repository. And there's a command file in that repository that literally pulls everything onto the local machine and then builds the SDK for .NET 7 from scratch. Now, there's obviously a bit of overhead in pulling all that stuff across the internet, but all up, the compilation of the .NET 7 SDK, once I had all the bits installed locally, was about 4 minutes from absolutely.
That's pretty fast for something that big.
Yeah, and I have to say that was also while I was running a Anaconda resolve in the background in a WSL instance running on the machine. So I wasn't running Outlook or anything else on the machine at the same time, but I didn't even really notice, there was no noticeable impact on either of those two processes from the other running. So for me, that's always been a big challenge as a developer, seeing, things slow down to the point where I can't be productive while some long-running task is going on in the background. And to your point, JT, if you do have mono repos and large solutions, this is going to be a good device to look at. Now, I think even going to the point of talking about Visual Studio 2022 and its 64-bit support. So if that is a developer environment and a Windows is your, or .NET is your developer framework of choice, this is probably going to be a really great device to look at for, you know, matching with VS 2022 and its 64-bit support if you've got large projects. And I don't know if you wanted to bring some light to maybe some of the other aspects of stuff that you looked at for this as well, JT. I've got some other points here, but want to give you an opportunity to explore something else.
Yeah, I think one of the things where this really shone, and it is something, you know, I've spent a little bit of my career as a mobile developer, and particularly cross-platform mobile apps. So you know, using tools like Xamarin and React Mobile and that sort of thing. One of the biggest pain points that I've always found in the past is the Android emulator is a very, like, that's a heavy app to run, particularly if you're running a development environment as well. It eats up a lot of resources. So I spun up an old Android. I haven't done any Android development for a couple of years now, but I spun up an Android app that I had lying around in my GitHub repo and spun up the emulator within Visual Studio. And it was like blazing fast, would probably be an understatement. It spun up and, you know, the thing, I was waiting for flames to start coming out of the side because that's typically what happens, and they didn't. So I was really impressed by that. And I also did some very light, we had for folks that have sort of been at Microsoft events in the past couple of years, Simon and I used to have, or still have, a physical pinball machine that learns to play itself. We had a software version of that that we could play around with to work on a self-playing or self-learning pinball game. I ran that up as well, just for something a bit sort of different and left field. And again, really sort of impressive performance with doing those sorts of things. So yeah, I'll pass back to you, Simon, but I definitely put this through a few weird and wonderful development scenarios to see if I could break it.
Yeah, look, it really reminds me, I know we talked a bit about it, that old XKCD, you know, single frame cartoon of the two stick figures fighting on chairs with wooden swords, and the boss standing in the doorway saying, "Get back to work," and one of them says, you know, "Can't, compiling." And I really think, you know, that unfortunately for those folks, this device might remove that as an argument in some instances. And I think
sword fights in the office.
Yeah, and we've talked a bit about, you know, the sort of desktop web mobile type developer experience, but I think this device, you know, game development is going to be a big part of doing this. The pinball emulator is in there working, and remind me, it's not Unreal, it was
Unity.
Unity. So it does use Unity quite heavily. So if you're doing a lot of game development, I think this device is really going to work for you. You know, Peter talked a lot about the virtualization capabilities. So if you are doing modern cloud native development with containers and Kubernetes, this is going to be a bit of a beast of a machine for you to be able to run a solid Minikube experience locally, so you can kind of get some of that developer rocking and rolling. I might wrap up. I know we had a question about you know, the TensorFlow capabilities of the device. So JT, I think you had the RTX 3050 or 3060. Yes. I forget which one it was.
You got the better one than me.
And I specifically asked for that device to give it a bit of a run through with some of the ML sort of stuff that's out there. And look, I will be the first to admit I'm not an ML specialist, but I probably know enough to be dangerous, let's put it that way. So I went and cloned a couple of quite well-known open source environments to really put them through their paces. And the one I sort of plumped for is quite an interesting model that takes old black and white photographs or video, in fact, and colorizes them using a GAN machine learning model. So I downloaded that, ran it. As Peter talked about, Kind of the limiting factor for this device on larger models is definitely going to be the available GPU memory that you've got on board. But I think where this device would work really well is if you are doing early stage proof of concept or exploratory modeling, where you maybe have a subset of your overall data to allow you to, come up with the idea before you move it to a larger scale environment, like potentially say Azure Machine Learning Studio, to allow you to kind of really explore that on a large data set. I would say that I managed to get Deoldify, which is the name of that solution that colorizes pictures. I actually got it running using the CPU. So they have a branch that will do CPU colorization, and the sample that they provide, it colorized the photo at a very high fidelity, probably in about 45 seconds, which for CPU bound work for something that's designed to run on a GPU is actually not that bad. I must admit, I didn't get the GPU version running because no matter what setting I took it down to, I ran into the memory as the limiting factor. So I think for me, good to do local proof of concepting for machine learning stuff, but you're probably going to take that to a larger scale environment longer term. So that's kind of the I guess the technical capabilities of the device. But what JT and I also looked at was, this isn't just a device purely for sitting down and coding. It has the capability when it's running in the laptop mode, but this is a multifunction device, right? It can do lots of different things and has a couple of other modes that you can use it in. So I know you've got a really great, story to talk to this, JT. So I might let you bring that to life.
Yeah, while I do that, Michael Cox has got a question in the chat around CPU versus, do you want to answer that while I ramble at people about this?
Yeah.
So where this really kind of, this device really popped for me, is you can see in that top, I've got to do my sides right, top left photo, that's actually my home desktop setup. And I normally have a laptop in clamshell mode, that just kind of sits there and powers everything and just powers those two honking great screens. What I found with this was, and Simon and I sort of bounced around who liked this feature and who didn't, but when it's in that stage mode where it's kind of, the screen's kind of flips down, like you can see in that bottom picture, like exactly like Michael's holding up, where you've got the screen and you've only got sort of the trackpad and the pen. Actually, if I have a normal laptop under those screens, I can't have it open because it obscures stuff. Whereas this puts just enough lean against it that I can actually use that as a third screen. I don't need the keyboard aspects of it because I've got an external keyboard, and I've got the ability to kind of scribble on that and whatnot. And then additionally, when I want to do, more sort of diagramming, architecture pictures, that sort of thing, I can flip it down and actually use it as a third screen and a tablet, but it's the single device rather than having a separate device for a tablet. And where this kind of resonated with me was in a previous life before Microsoft, I was a tech lead for an organization. And so my day was, how much coding can I fit in and then run between as many meetings to kind of, so that my team wouldn't have to go to a bunch of boring meetings. How do I run around, take notes, and then bring that back to the team to sort of help them understand where everything is. And, historically how I'd done that was I would leave the laptop on the desk and I would take a separate tablet with me. And I was like, if I had this device, it would have made running up and down stairs in that building to go to different meetings and then come back and try and, help with some tech stuff. It would have been a completely different experience for me. And I think the ink aspect of, like, I use a whole bunch of other products from other companies, but when it comes to ink, digital ink, I still haven't found anyone that can do this as well as Microsoft can do this. And so when you sort of bring that into play with the new Surface Slim Pen, this is just an awesome device. If you're on a campus or in a large building, this has got the portability that I would like, but without the compromise on performance when you get back to the desk. So, having it docked and then just being able to undock it and run to the next thing was something really, really interesting for me. And it was the sort of thing where I was like, man, if I'd had this 3 or 4 years ago, this would have been an absolute game changer for me.
Sorry, I'm just typing the answer to one of Michael's questions. But yeah, no, look, I think being able to work like this, I had always previously looked at the Surface Book when it first came out, and the idea that you could have this tablet to go to a meeting with and scribble on and use inking to take notes. But to Peter's point, I'm not sure how many people really ever detached the screen from the Surface Book and use it as a standalone tablet. I think the way that this folds down over the keyboard also makes a lot more sense to me than the way you could fold over the Surface Book. I think just having that one device works well like that. But for me as a tech lead, I would have loved to have had a device like this where I could be productive as a coder, and then I could also be productive in a meeting without necessarily having to have the screen up and have people feel like I'm not paying attention in the meeting, right? I think tablet mode gives much more of an impression of attention in a meeting because you don't have that screen up in front of you, right? So I think that is also a bit of a game changer. The studio, the stage mode, which is kind of that middle one. I also think if you're doing training or you're watching videos of any sort, then that's a really useful format to have it in because it's completely hands off. And I think the pen is a must. Like I really think to get, if you're going to use the device in either the tablet or the stage mode, I really think you need to have a pen to go with it. Otherwise, you're going to miss out on a lot of the benefit of using the studio in the way that it's really designed to be used. I think that's pretty much it. Do you have anything else that you wanted to add, JT?
No, not really. I'm just typing a Chong. I'm just addressing. Sorry, Patrick.
Yeah.
I'm just addressing yours in the chat. But no, I agree with that. I think the pen, Windows 11. I think like this device really lights up when you have those two things, and it's incredibly versatile. Is if I wanted you to take away a single idea, it is this idea of we're actually now at a point where a single device can do all the things that you need to do, for sure.
Yeah. Look, I answered Michael's last question, but I think, Peter talked to the fact that this is a mobile device first and foremost. So some of the capabilities of, say, the GPU will differ from what you'll get in a full-blown desktop setup, just purely because of the thermals and the design, to fit into such a form factor. But I still think you can be highly productive using this as a device. Look, thank you very much, everybody, for listening to JT and I ramble on about developer stuff. Back to you, Michael.
Thank you. Thanks, guys. That was really good. Like when it comes to your desktop setup, that's kind of like my work setup. I've got one big monitor. I put it in stage mode underneath. So I've got like the best webcam and I've got an external keyboard. So I kind of do it very similar. I also think stage mode is pretty good for writing on. It just gives you a nice angle. And I think even just the solid base or even laptop mode is what some people have preferred over our pro devices, which have the kickstand and are not always as lappable as laptops, really. And so, yeah, I've kind of used a mix of all of them. And the other one that I've been using, and I've kind of got it set up now with a different PC, is one big screen in front and one to the side in tablet mode. So I've just got that as a second screen up on the right. A little bit harder to write in the air. That's where stage mode can sometimes be a bit better. But yeah, I've kind of used almost all the modes that you can. So thanks for that. That was some really good insight there. I'll now just remind everyone that we do have a session next week as well. So if we don't get to anything this week, and also if you wanted to see some more examples in health or government or telehealth, that's what we're going to cover next week. But please register for those. We'll chuck a link in the side. But we've still got some more time to answer questions. We're going to stick around. Please ask us, come off mute if you'd like. But I think we've kind of answered some of the things in the chat.
Yeah. Why don't we actually answer a couple of them verbally? Because there was a point that Man raised around the USB charging. I just wanted to provide a bit of clarity on that. It will do if you have enough power running through that USB-C port, the power delivery will take enough power to power the device on its own. However, most external docking stations and things like that that use that don't provide that 100 watts of power. So you may see that it draws on the battery if you're not getting enough power through that channel. That's why one of the reasons using the actual SurfLink power adapter is wise. It's just something to be noted. If you're not getting that power, you're in a slow charging mode, and you are using it hard, you might be drawing on the battery.
Yeah. So I've tried a few different ones as well. So the big super widescreen Dell that I've got in the office runs fine. Even when I put it in performance mode, it does the power delivery. There's two chargers, or two sizes of charger that comes with the Surface Laptop Studio. If you're going for the Intel only GPU, that's on the entry level i5. It's a 65 watt charger, and if you're using i7 and also anything that's got the GPU, NVIDIA GPUs in there, it's 102 watts. So, if you kind of follow that when it comes to USB-C power delivery, that's kind of what you need. But really, if you plug it in, it'll tell you as well. If I plugged in a lower wattage Surface adapter, or plugged in one of those USB GAN chargers that is only 65 watts, it'll tell you. It'll tell you that it's on slow charging mode, or it might put it down to a lower performance level.
I think that's the key thing for me as well, is this device is designed to ensure that the chips are kept at the most performant. Often in mobile devices, you will find throttling occurring, which when you're doing CPU intensive activities, you may not necessarily notice it all the time, but you will notice it if you're doing really heavy duty large scale app development. So I think for me, I know some of you on the call may not have seen a device physically yet, but when you see it the first time, Michael showed you the sort of the underside where you've got the fan entrances right along the bottom on both edges. It is a fairly thick base, but it's designed to be like that so that you retain the performance, because oftentimes, in your Ultrabook and other types of devices, they're built to be light and thin and small. And they do that at the cost of trading off the performance, particularly when they're hot. So, it's a different type of device, and it's designed for performance first, and maybe not ultra portability in this first instance, but it's definitely nothing too hard. I think the slide earlier said it was like 1.7 kilos for this device versus 1.5 for the Surface Book. So it's not a light device, but it's by no means a heavy device physically either. So yeah, that's kind of my take on it.
Portable workstation sums it up a bit for me.
And that's the design. That's the thinking that we went to. With all devices and everything, there is give and take. There's a healthy amount of tension in any scenario. So as you sort of said, JT and Simon, having this device to be able to take it to meetings, to do the other things, all the while having your processing going on and compiling code, etc., and having the grunt to be able to do that as your mobile is really what we went for. And there's reasons, as we said before, that lots of people might ask, hey, why didn't you put an i9 in this and a 3060 Ti with more RAM and all this sort of stuff? And it does come down to that tension and the give and take that's required to be mobile and be a truly mobile device, as well as if you put an i9 with all of that stuff in and the extra cooling that requires, your battery life will shrink to a very small amount. So it is absolutely a balancing act to get these devices to fit the right mark for the broadest amount of people. So that's what we think about. And I'd love somebody, if there's any questions, any concerns, or any advice that they might want to give, any things that they might like to see on these products, let me know. I'm more than happy to listen.
I might just grab Man's question. You're asking, does the screen have to sit on its base in stage mode? So let me just show you kind of the fully flipped around laptop mode. So laptop mode, if you flip it all the way around, you can see the woven hinge in there, and that's how it kind of sends all the data and everything through to the top of the webcam and the screen. But stage mode, I'll show you here, it does not hover above. I think you're asking kind of, can it stay in that mode so you can, on a plane, squeeze your fingers under and type? No, it doesn't. It locks in place by a couple of magnets on the base there, and you can see it kind of click into place there. So you've got laptop mode, you've got flip it all around mode. So I guess you could show someone behind you, and the display flips as well. So again, laptop, stage, and it clicks just on it into a couple of places on the base there, and then flat into tablet mode.
Yeah, it is a free form hinge that screen runs on. We did do quite a lot of design work in that space because as a lot of other users out there might understand, that the more you move something, the more wear goes on that particular part. And there's actually a design in the base of that allows the cabling to move and stretch, so it doesn't actually flex in the same way and have that high flex point. So yeah, yeah, we do love a hinge surface. So yeah, but we did take a lot to design that, to give it that longevity. And the other thing about this particular product is we did design it with longevity in mind. It is one of the most repairable devices in the Surface fleet. So really getting that bang for buck out of this device is what we're targeting. The hinge makers, I love it.
I think there was another question in there about Thunderbolt 4 and external GPUs. I think Thunderbolt and eGPUs really do open up kind of a lot more options, not just super fast storage, but, external GPUs. And Brett, I think you've been thinking about playing with one for a gaming reason, maybe even a productivity reason. But I've seen even the Pro 8 do some pretty impressive, like AAA gaming stuff, and all down and up one single cable. Either offloading the GPU stuff and then displaying it back on, the Pro 8 screen, for example, or kind of one way out to the GPU and then out to a monitor, I think provides a bit more throughput. So I've seen, even the Pro 8 can do some pretty heavy stuff, but then I guess you're also choosing between different types of processors. You've got on the Pro 8, the low voltage 15-watt processors, and then on the Studio, the H series, which will give a bit more grunt and could have been, a bottleneck on the Pro 8 for some applications. But Peter, Simon, JT, anything to add to, what you could do with Thunderbolt?
I just wondered if it had any developer applications.
So, well, JT and Simon are probably better on the developer space, but yeah, it'll absolutely support all those bits of hardware down that Thunderbolt port. So the port is the only limitation, really, and the CPU, being the H-class CPU, will be able to hold up its end of the bargain when you're doing these processes. So it as sort of, I think Simon mentioned before, it depends on exactly what you're processing. If it's AI or Tensor and it's all GPU based, then that processing is going to be the majority there. But as you know, that's not always the case. So yeah, and for your crypto mining, it'll all happen on the GPU. So.
I think Peter pretty much covered that. The port hardware will support a range of external devices. So I think really it's going to depend what you're developing and what hardware you want to use. And if the inbuilt CPU and memory and disk and the disk I/O isn't up to it, you can always attach via a Thunderbolt 4 port. But the reality for me is, if you're at that point, you're probably, to my mind, in the minority. The external GPU, I can see that some people might want to use that to boost the capabilities of this device, but I would say for me as a developer, the least amount of stuff that I can attach to a device so that I can be productive anywhere, the better for me. And particularly previous lives as a consultant, the last thing you want to be doing is having to carry a bag full of kit with you. The less you have, the better. So this thing kind of ticks that box for me.
The other part of it as well is, if you're really doing heavy lifting, then you're probably going to be wanting to do that processing in the cloud or somewhere, not necessarily device based. This gives you the option to do what you can, and the that sweet spot of what you can do on your device. But if you do need to push up higher, then yeah, I'm sure you two would both spruik the benefits of Azure and processing in the cloud.
Look, the reality.
Thank you for the Azure plug, Peter. Appreciate that.
I think the reality is, in an ideal world, we'd be talking about cloud-based services to do a lot of that stuff. The reality is that we have a broad spectrum of developer experiences, and our industry doesn't always, everyone is not working at the leading edge in our industry. We have applications that are 10, 15, 20, maybe more than that years old, that continue to need a more traditional tool set, and a locally bound, the capabilities of the hardware you have in front of you are what are going to drive your experience. So for those people, I think that this is a good grunty machine that will mean that you've got, runway to get to wherever your ultimate nirvana is going to be. So yeah, I'll leave it at that. That's it from my side.
Michael Cox, I think you asked a question about, CPU versus GPU workloads. I think it's very just application dependent. So, one of the first things I tried, because I know it's super heavy on processing power, was using Handbrake to transcode video. So that really takes a lot of CPU grunt, and I was trying to see, has it had an update? Does it actually offload this to the GPU? And no, not in the case that for that. But the H-class processor certainly sped it up like 3 times over the Book 3. And I think even though the Book 3 could burst quite well, just sustained transcoding, because it can go for an hour or so, depending on how big the file is. And really, you can hear the fans go up on the Laptop Studio, but it just means it can just sustain that CPU grunt. But I think the slide that Peter showed earlier showed, the list of certified apps, and that kind of gives a guide on what app is certified and what GPU is at least certified for that application and best for that application. Anything to add to that, guys?
Yeah, I actually, interesting you mentioned Handbrake. I actually got Handbrake encoding running on NVENC, offloaded to the GPU. So you can do it. I might have a chat with you about that. Good. Transcoding Titanic Blu-ray at Super HD. I don't own Titanic on Blu-ray, sorry, Simon.
Sure.
Just part of the DiCaprio collection, huh?
We've got a couple more minutes if you've got any questions for us. And again, we've got a session next week that we'd love you to join as well, just to see some other use cases.
No.
Thank you. All right. Well, I think Josh has pinned a message there with some links. Again, thank you for joining today. I'm really enjoying the Surface Laptop Studio. And thanks again to JT and Simon for having a play around. And I definitely glad you joined, because I don't know what you were talking about a lot of that time, but I'm sure our audience did. And again, thanks, Peter, from engineering. And hopefully I'll see a few of you next week again. So thanks for joining. Enjoy your day.
Thanks all.
Bye, everybody.
Thanks,
Thank you.